Imagine a world teeming with life, a world where the air is thick with the calls of strange creatures, and the ground shakes beneath the weight of enormous beasts. This is a world that existed millions of years ago, a world that we can only glimpse through the remnants left behind. Giant reptiles roam the earth, their massive forms casting long shadows over the land. These creatures, known as dinosaurs, dominated the planet for over 160 million years. Some graze on ferns and other lush vegetation, their long necks reaching high into the trees. Others, with sharp teeth and claws, stalk their prey with a deadly precision. The balance of life in this prehistoric world is both beautiful and brutal. These are the dinosaurs, rulers of a vibrant planet. They come in all shapes and sizes, from the towering Brachiosaurus to the swift and deadly Velociraptor. Each species plays a unique role in the ecosystem, contributing to the rich tapestry of life. For millions of years, they thrived. But then, something happened. A series of events that would change the course of life on Earth forever. Something catastrophic that wiped out these magnificent creatures. An asteroid impact, volcanic eruptions, and other natural disasters combined to create a perfect storm of destruction. What caused this mass extinction? The once thriving landscapes became barren and lifeless, a stark contrast to the vibrant world that existed before. It's a question that has puzzled scientists for centuries. Paleontologists and researchers have dedicated their lives to uncovering the truth, piecing together clues from the fossil record. The answer, it turns out, is more complex than anyone imagined. It wasn't just one event, but a combination of factors that led to the demise of the dinosaurs. The extinction of the dinosaurs wasn't a single event, but likely a combination of factors. Massive volcanic eruptions spewed ash and gas into the atmosphere, blocking out the sun and causing drastic climate changes. Some were sudden and violent, like the asteroid impact that created a massive crater and sent shockwaves around the globe. Others were gradual and relentless, like the slow but steady changes in climate that made it difficult for many species to survive. Together, they spelled doom for the dinosaurs and many other species on Earth. The fossilized remains of these creatures tell a story of a world in turmoil, a world that was forever changed by these catastrophic events. Let's journey back in time and explore the theories surrounding this ancient mystery. By understanding the past, we can gain insights into the forces that shape our world and the delicate balance of life on Earth. One of the most widely accepted theories is the asteroid impact. Picture this: a massive rock 6 miles wide, hurtling towards Earth at an incredible speed. The impact would have been unimaginable.
The force of the impact would have been equivalent to billions of atomic bombs. Earthquakes would have ripped across the planet, triggering volcanic eruptions on a global scale. The skies would have darkened as dust and debris choked the atmosphere. This event, scientists believe, marked the beginning of the end for the dinosaurs.
The immediate aftermath of the impact would have been catastrophic. The impact itself would have vaporized millions of tons of rock, sending superheated debris hurtling back into the atmosphere. This debris would have rained down on Earth in a fiery inferno, igniting wildfires across the globe. The heat would have been intense enough to incinerate anything in its path. The dinosaurs, despite their size and strength, would have stood little chance against this global firestorm. But is there any evidence to support this catastrophic theory? The answer, it turns out, is a resounding yes.
In 1980, scientists discovered a massive crater in the Yucatan Peninsula of Mexico. This crater, known as the Chicxulub crater, is over 110 miles wide and dates back to the time of the dinosaur extinction. The size and location of the crater strongly suggests that it was formed by an asteroid impact.
Section 5. The smoking gun. Further evidence comes from the layer of iridium found in rock layers around the world.
Iridium is a rare element on Earth but common in asteroids. The layer of iridium found at the time of the dinosaur extinction is remarkably consistent, suggesting a single global event.
This iridium layer is like a giant smoking gun pointing directly at a massive asteroid impact as the cause of the dinosaur extinction. Section 6. A world in flames. While the asteroid impact was undoubtedly a major factor in the dinosaur extinction, it may not have been the only one.
Around the same time, another catastrophic event was unfolding on Earth: massive volcanic eruptions. These eruptions were spewing out lava and poisonous gases into the atmosphere, further contributing to the environmental chaos.
Section 7. The Deccan Traps. The most significant of these volcanic eruptions occurred in what is now India.
These eruptions, which lasted for thousands of years, formed a massive volcanic region known as the Deccan Traps. The Deccan Traps are one of the largest volcanic features on Earth, covering an area larger than France. The eruptions that formed the Deccan Traps would have released massive amounts of carbon dioxide and sulfur dioxide into the atmosphere.
Section 8. A Changing Climate.
These gases would have had a profound impact on the Earth's climate. Volcanic eruptions are one of the most powerful natural events on our planet. When a volcano erupts, it releases a mixture of gases and particles into the atmosphere. These emissions can include water vapor, carbon dioxide, sulfur dioxide, and other trace gases. The immediate aftermath of an eruption can be dramatic, with ash clouds darkening the sky and lava flows altering the landscape. Carbon dioxide is a greenhouse gas, which traps heat in the atmosphere. This process is essential for maintaining the Earth's temperature, but an excess of carbon dioxide can lead to global warming. The greenhouse effect occurs when carbon dioxide and other greenhouse gases absorb infrared radiation from the Earth's surface and re-radiate it back, preventing heat from escaping into space. This trapped heat leads to an increase in global temperatures, which can have far-reaching consequences for our climate. The massive amounts of carbon dioxide released by the Deccan Traps eruptions would have caused a significant increase in global temperatures. The Deccan Traps, located in present-day India, were formed by a series of volcanic eruptions that occurred around 66 million years ago. These eruptions released vast quantities of lava and gases, including carbon dioxide, into the atmosphere. The resulting increase in greenhouse gases would have led to a warmer climate, potentially contributing to the mass extinction event that marked the end of the Cretaceous period. Sulfur dioxide, on the other hand, has a cooling effect on the climate. When sulfur dioxide is released into the atmosphere, it can form sulfate aerosols, which reflect sunlight back into space. This reflection reduces the amount of solar radiation reaching the Earth's surface, leading to a temporary cooling effect. However, this cooling is often short-lived compared to the long-term warming caused by carbon dioxide. However, the sulfur dioxide released by the eruptions would have eventually fallen back to Earth, leaving the long-term warming effect of the carbon dioxide. Over time, the sulfate aerosols would settle out of the atmosphere, and the cooling effect would diminish. The persistent presence of carbon dioxide, however, would continue to trap heat and contribute to global warming. This complex interplay between volcanic emissions and climate highlights the delicate balance of our planet's climate system and the profound impact that natural events can have on our environment.
Section 9. Clues in the rock.
The evidence for these climate changes is preserved in the fossil record. Studies of ancient plant and animal fossils show that the Earth's climate was in a state of flux in the late Cretaceous period, leading up to the dinosaur extinction. These climate changes would have put additional stress on the dinosaurs, making them more vulnerable to the catastrophic events that were to follow.
Section 10. A perfect storm. Section 11. The mystery continues. The extinction of the dinosaurs is a stark reminder of the power of nature. This cataclysmic event, which occurred around 66 million years ago, wiped out nearly 75% of all species on Earth. The exact cause of this mass extinction has been a subject of intense debate and research for decades. And the fragility of life, the dinosaurs, which had roamed the Earth for over 160 million years, were suddenly gone. Their disappearance left a void in the natural world, paving the way for the rise of mammals and eventually, humans. While we may never know exactly what happened on that fateful day, the evidence we have gathered paints a vivid picture of a world in chaos. From massive volcanic eruptions to the impact of a colossal asteroid, the theories are as varied as they are fascinating. The evidence we have gathered paints a vivid picture of a world in chaos. Imagine a time when the skies darkened with ash, the ground shook with violent tremors, and the air was filled with the roar of erupting volcanoes. The impact of the asteroid alone would have caused massive tsunamis, wildfires, and a nuclear winter effect, blocking out sunlight and drastically cooling the planet. The study of the dinosaur extinction is ongoing, and each new discovery adds a piece to the puzzle. Fossils, geological formations, and even tiny particles trapped in ancient amber all contribute to our understanding of this monumental event. Scientists are constantly making new discoveries that shed light on this ancient mystery. Advanced technologies, such as radiometric dating and computer simulations, allow researchers to reconstruct the events leading up to the extinction with greater accuracy than ever before. By studying the past, we can gain a better understanding of the present. The extinction of the dinosaurs serves as a powerful reminder of the delicate balance of our ecosystem and the potential consequences of sudden, dramatic changes, and prepare for the future. By learning from the past, we can better anticipate and mitigate the impacts of natural disasters, climate change, and other global challenges. The mystery of the dinosaurs' extinction continues to captivate and inspire, driving us to explore the unknown and seek answers to the questions that shape our world.